So what we need to do, we need to select, I will send you this file actually in which everything is in detail, that how you will open your PDB file. So first of all, we have to open any PDB file. We will select in PyMol and we will remove all the water molecules. And here for you people, I have selected a project actually, that why not you people select, okay, I don't know why it's not hiding the upper bar. Anyway, so you will go to PDB, and in PDB, then you need to search acetylcholine esterase. When you search acetylcholine esterase here, then let me just move it here. And then what you will see different options, and then you have to select Homo sapiens like last time we did. And then here you can see different acetylcholine esterase which belong to Homo sapiens. I have selected 7E3H. So this is actually very good human acetylcholine esterase structure, which is present in complex with the donepezil, which is actually a drug which works against acetylcholine esterase. So how you can download the structure, as we have discussed already, we go to files and here legacy PDB format. I will click on it and it will automatically download for you people. Okay, or you can use another structure for your practice for acetylcholine esterase, and that is 4-MOE. So these two structure, and this is also present in complex with dihydrotensionon 1. So it is present in this particular form. So we have just downloaded these two structures here. And now what we need to do, we need to open this structure. I will open this particular structure into the PyMol. And what my guide says, what I need to do, I need to remove all the water molecule. Remember, I'm not going to open this file. We are going to open our own project actually, not the given files. So I will open the PyMol, and PyMol will open my required file. Where is my PyMol? Actually, many things are opened here. So this is the PyMol and it has opened 7E3H. Here you can see, if you analyze the structure, that these are actually the two chains. How I can see? I can go to color, and I will say it by chain. And here you can see there are two chains are present, and these red things, these are the water molecules. So I will go to action, and then I will remove all the water molecules here. Here you can see the water molecules have been removed. And in the sequence, if I go to this particular button sequence, I can see it here. This is A, chain A, and then this one is actually the chain B. And here are a few things like E20, that is some ligand molecule is present. And even at the end here, you can say there are certain NAG and acetylglucosamines are present, FUC is present. So there are a lot of different molecules are present. I know I don't need these things. I will select them and I will remove them. Okay, then what is left? Left is E20 actually. What is E20 here? E20 is the donepezil. So what I will do here, I will go to this particular thing, and then if I want to see this, that I want to see this particular structure, I will say it, center it, it will center it, and then I will just zoom it here. And if we don't wanna this structure, actually with the mouse, you will be very easy. You just scroll it down and then you can center it. And on the Windows laptop, I am getting few problems in zooming that. Anyway, I will just orient it out. Okay. And here, if you wanna delete these organic molecules, then you will select this one, and then you will select this one, and then you will remove it. So here we need just only one chain. We don't need the other chain. So last time we have discussed that there are few ways of doing that. I will select this one, press shift, go there, it will be selected, and I will just remove this. So this is the one way, and then I will orient it. This is one way of doing that. So this is my molecule, which consists of one chain, no water molecules, no organic molecules. I will go to file, and then I will export the structure. I will export the molecule actually, and I will save it. I will save it by making a folder. Like in the desktop, I have made a folder like docking, and I'm gonna save it into PDB file, and I'm gonna save it in form of receptor dot pdb. So this is our receptor. This is how we have prepared our protein file actually. Okay. So our PDB file is now ready that we can open it into the AutoDock. Okay. One another thing which I wanna show you, that if I wanna, I will just reopen my file here. So I will reopen that. So if I wanna extract only this ligand molecules actually, and E20, which we call, because we wanna use that as a ligand. So I will go to this particular thing, and here you can see, whenever I select something, a selectable thing that appears here. I will say it extract the object, so it will extract it. So this is my actually E20. I have extracted it. So I don't need the rest of the object. So my E20 that is now present here, this is my ligand molecule. So this is my donepezil. So I will go to the file, then I will say it export structure. I will not change anything, and I will say it ligand dot pdb. So this is how, and I will save it where? I will say desktop, docking, and save it. So in my folder, I got my ligand molecule and I got my protein molecules. So both things are present here. So this is one way. And then in AutoDock. So AutoDock, when you will install AutoDock, then there will be an option that you can search AutoDock tools here. When you go to AutoDock tools, a menu will appear, and then automatically it will load up, and then AutoDock will be appear. And then again, you need to follow this particular guide, which is pretty easier to do the things. So this is my actually the AutoDock. Okay, let me drag it and make it a bit big. Just give me 2 minutes. Okay. Here, let me just move this screen. Okay. Okay, this is now here. Okay, let me go to what we need to do. We open our PDB file actually in AutoDock tools. So I'm gonna show you one trick actually. Let me just make it bigger. I don't know how I can. Okay, why not? I just make it big from here. Okay. Okay, it's here. So here you can see that we need to do open it into ADT. But before that, I want you to do one thing. I cannot see due to this bar. Okay. I will go to file and I will go to preference. In preference, I need to set a directory here. I will go to set, and then here I need to check my working directory. In my working directory, I have to put it, the working directory, as the docking, which is present where, which is present on my this folder. So I will go here, I will click here, I will do Control C, and I will press here Control V, and I will set it. So this is how I will set my control directory. So every time when I say open something, it will directly go to that particular directory. So I will open my receptor molecules here. When I will say it, open the receptor, my protein molecule will be opened here. So protein molecule, you can also analyze it here. This is only A chain. These are the amino acids which are present here. So because we have already prepared it, we don't need to delete the chains or other things. You can do the things which you have done on PyMol, but that is bit difficult here in this AutoDock tool. Okay, when you will open it, you will read it. Now you can rotate, you can see it, whatever you want to do. And now we want to add the hydrogens to target structure. So edit, hydrogens, and add. So, okay, how I can move actually this bar. Okay. Okay, I don't know why it's my zoom bar is not moving from the top. Okay, I think I let me wait here and then it will move a bit up. So what we need to do, we need to go to edit. So I will go to Alt. So it's not moving. Okay, let me, can I hide this actually? This bar. Okay, I cannot hide it actually. Okay, I cannot see the things on the top due to this bar. Let me stop the sharing and then just bring it back. Okay, I have made it a bit lower here. Okay, so what instruction says? Instruction says edit hydrogen and add, means you need to just follow that. Edit, and then here you can find different options like the bonds, delete something, atoms, delete waters. If we haven't delete water, we can delete it here. Hydrogens, then add. It will ask us which hydrogen you want to add. I will say it only the polar ones and not the other ones. Polar ones, and okay. So it will, you can see it here, the white things it has added. So all these white things, actually, these are, let me make it a bit bigger so you can see, but it's usually hide under the zoom bar. So these white things are actually the hydrogens. So hydrogens has been appeared. So go to file, save, and write pdbqt. Very simple. File and save. Here are different options. pdbqt is a format which is called the AutoDock format, which contains the charges actually. So it says file, save, and pdb. So I will go to file, save. Why I am not going to pdbqt actually? Because when we will be preparing it for the docking here, then we will just put it into the pdbqt format. So we can also do directly converting it pdbqt, but it always asks us again and again. So write pdb. I will not touch anything. It's already in my docking folder. I will write it down. I will overwrite it. Okay. You can also make pdbqt actually. If you want to pdbqt, you can make pdbqt, but here you can see that it has given certain options. I will say it okay. It's saying cannot create pdbqt because the charge field is not selected. Again, that's the issue, because when you are preparing it for the docking from here, it will add the charges and Q is basically thing which involves the charge. So we will save it from here, but we are not gonna save it now. So we have saved the file, we have prepared it very well, and then we will prepare the ligand molecules. The ligand molecules, they are prepared. So we will hide the protein here. Hiding is very simple. I will just go here and protein will be hidden. And then ligand input and open. I will go to ligand. I will say it input. I will say it open. So first time is open. Next time, whenever I will be doing opening the ligand molecule, I will go to choose. But the first time you need to open it. Okay, now it's giving me options here. It's not showing my ligand molecule, but here are certain options. You can change it. I will change it to PDB. I will select the ligand molecule, and it says this is a summary for ligand. It has added Gastesia charges. It has found 15 aromatic carbons, 6 rotatable, or whatever it is. Okay, I will say it okay. So this is my ligand molecule, which is present into a very good three-dimensional shape. So what we need to do, we need to detect the root of that particular ligand. Okay, I'm again back. So I will go to the, it says we will go to the root of the ligand by ligand torsion angle and detect root. Root means where the particular ligand is going to start and going to grow. Okay, so it says us I have to go to ligand, torsion tree, and detect root. So in ligand, we got torsion tree and detect root. We can also choose the root. We can also choose the root, this. But here for now, we will detect the root. It has automatically detected this root, that this for macro4, it has start growing from here to here. So its grow was in this direction and in that particular direction. So next, we need to look at the torsions. What are the rotatable bonds present? As we have seen that poses, they depend on the torsion trees. So I will go to the ligand, and then here you can see again the torsion trees. Choose the torsion, set the number of torsions. So we have many options. If we choose the torsion here, then here you can see we got many options. If I can move this box, actually, I don't know I can move it in Windows or not, or how I will move it. Anyway, here you can see the green bonds, they are rotatable bonds actually. And here magenta one, they are non-rotatable bonds. And here are the red ones, and these red ones, they are the unrotatable actually. So we got 6 out of 32 actually, which are 1, 2, 3, 4, 5, 6. 6 bonds, they are rotatable. So what we need to do, we need to set the number of torsions, okay? And then we need to actually, I will just keep it by default. I will not change it, and I will just do it done. So it has just changed it. Usually we put the number of rotation to 6. Then we need to save it. We will save it into PDBQ format actually. I will go to ligand, and then here are certain option of output, and then here is an option. Then I will save it into ligand file. Okay, now we have saved it. Then the next option, we have prepared these two files actually. One is the file which belongs to receptor, other belongs to ligand. So we can hide it, we can open it. And next thing is preparation of the grid map actually. The grid map, now how we can prepare the grid macromolecules. And now macromolecule is already open. But if you have opened the ligand molecules already, then you can open them. If you have just made in this session, then you can choose it. So I know receptor was my molecule, I will just choose it. So it says initializing receptor PDB contain no bonded atoms. There are no issues. You can save it into PDB QT format now. So I will save it into PDB QT format. And now in the next thing, what it says, select the ligand. So I need to select the ligand by selecting grid, set map types, and choose ligand. Great. and then set map type. And now we can also directly choose it by clicking here and clicking in this window, or if it's appear here, we can choose it. So ligand was our ligand. I will select it. So it has also selected the ligand. Now it know what is ligand and what is other thing. And now I ask it for the grid box. Set the grid box. So I will go to the grid thing. And now here you can see our option is grid map. So grid map, how we can prepare it, that is a bit tricky. Usually what the people do, they just put everything inside the grid map, or we can say it, center it on the ligand, center it on the macromolecules, and then you can make it bigger into the different directions, into X, Y, Z direction. You can make it bigger and then you can visualize it here. So if I say I am putting it at 100 by 100 by 100, depending on, I am not touching anything in this spacing. In these offsets, we can also select them, that where we want certain offset, where we want to start this grid box, where we want to stop this grid box. So this window is actually very small, so you cannot see it properly, and I don't know why it's not getting big. Anyway, and then you will go to file and then output the grid dimension file, and then you will output the grid dimension file. So to save it for the further thing, I will say it for grid, and I can save the grid dimension file actually. So we don't need center. And if you want to see the box here or not, you can just change this option. So I will go to file, I will say it close, saving the current. So it will save my grid box actually, whatever it is. And then grid output. So when I will go to grid and output, actually, it will output in form of the grid parameter file. I will just name it as grid GP. If already there, I will say it grid parameter file here, and I will save it. And then next, setting the parameter of the docking file actually. Then you will go to the docking thing, macromolecule. And now you already have selected the macromolecules and the ligand molecules. So, and then there is a docking parameter file. This was grid parameter file, which we have outputted. If we want to save it, we can save it like this. So I will stop it here today, that how we can prepare the grid parameter file, grid mapping file actually. And then for the grid, for the docking file and docking things, I will keep it to you people. So just follow this tutorial and do it for a while. If there is any issue, we can discuss it. And I will also show you on Thursday. Thursday, we have the session at the same time, 5:30, and I will show you how to